Welcome to the channel. Please consider subscribing. I produce videos daily, covering a wide variety of cloud topics with a focus on networking. Also, hit the bell icon to get notified of new videos. Today, we're going to explore a very powerful and efficient architecture in Google Cloud, using a cloud storage bucket to serve content through a global load balancer. This is a fantastic solution for hosting static websites or serving assets like images, videos, and scripts for your applications. The core challenge is this: cloud storage is a serverless product, meaning it doesn't have fixed IPs like virtual machines do. So how do we point a sophisticated load balancer to it? The answer lies in a special tool called a serverless network endpoint group, or serverless NEG. Let's dive in and see how it works. What is a serverless NEG? Before we build our solution, we have to understand the key component: the serverless network endpoint group, or NEG. A NEG is simply a way to group backend endpoints for a load balancer. But a serverless NEG is a special type. Think of it this way: a standard NEG is like a list of street addresses for a group of houses you own, which are your virtual machines. The load balancer knows exactly where to send the mail. A serverless NEG, on the other hand, is like a special, official PO box for a service that doesn't have a fixed street address, like Google's own cloud storage or cloud run services. You, the user, create this NEG, which acts as a stable, internal pointer to your specific serverless service. You then attach this pointer to your load balancer. It's the essential glue that allows Google's load balancing infrastructure to connect with its serverless infrastructure. You might be asking, can't I just serve content directly from a cloud storage bucket? And the answer is yes, you can. However, putting a global external HTTP/HTTPS load balancer in front of your bucket unlocks a whole suite of powerful features that are essential for any production application. First, it gives you a single, global anycast IP address. This means users all over the world connect to the same IP, and Google's network automatically routes them to the nearest point of presence for the best performance. Second, it provides seamless integration with Cloud CDN, allowing you to cache your content at the edge of Google's network, which dramatically speeds up load times for your global users. It also lets you use Google-managed SSL certificates for free, effortless HTTPS. Finally, you can protect your bucket with security services like CloudArmor, Google's WAF and DDoS protection service. These are all critical features that you don't get when serving directly from the bucket. It's critical to choose the right type of load balancer for this job. Because we are serving web content to users on the internet, we need an external load balancer. And because our users are global and we want to use Cloud CDN, we need a global load balancer. Most importantly, we need a Layer 7 HTTP/HTTPS load balancer. Let's use an analogy. A Layer 4 load balancer is like a mail sorter who only looks at the zip code on an envelope. It's fast but simple. A Layer 7 load balancer is a more advanced sorter who can read the full address, including the person's name and the specific request inside the letter. Since cloud storage communicates using the HTTP protocol, our load balancer must be able to understand HTTP requests, which only a Layer 7 load balancer can do. Therefore, the global external HTTP/HTTPS load balancer is the only correct choice. Step 1. Creating the serverless NEG. Let's get practical and walk through the gcloud commands to build this. The very first step is to create the serverless NEG itself. This command creates a special pointer to our cloud storage bucket. The command is gcloud compute network endpoint groups create. We give it a name, for example, my GCS neg. The region flag is important. Although the final load balancer is global, the NEG resource itself is regional and should be created in a region that makes sense for your management purposes. The crucial flag is network endpoint type, set to serverless. This tells Google to create the special NEG type that can point to serverless products. Finally, The Cloud Storage Bucket flag is where you specify the exact name of the bucket you want to serve content from. After running this, you'll have an NEG resource ready to be used as a backend. Now that we have our NEG, we need to create a backend for our load balancer and attach the NEG to it. In Google Cloud, you do this with a resource called a backend service or a backend bucket. For cloud storage, the simplest approach is a backend bucket. The command is gcloud compute backend buckets create. We give it a name, for example, my GCS backend bucket. We use the GCS bucket name flag to point it to our storage bucket. The most important flag here is enable CDN. By adding this simple flag, we are telling the load balancer to turn on the powerful Cloud CDN service for this backend. This will automatically start caching our bucket's content at Google's edge locations around the world, which is a huge win for performance and cost. With our backend ready, it's time to build the front end of the load balancer. This is the component that users will actually connect to. First, we create a URL map with the gcloud compute URL maps create command. This is the traffic director. It tells the load balancer that for all incoming requests, represented by setting the path matcher name to all paths, it should send the traffic to our MyGCS backend bucket. Next, we create a target HTTPS proxy and an SSL certificate. This proxy is the component that handles the HTTPS handshake with users, using the certificate to encrypt the traffic. Finally, we create the global forwarding rule. This is the command that creates the public, static IP address for our load balancer. We use the gcloud compute forwarding rules create command. With this command, we specify that the rule is global, point it to our target proxy, and set the ports to 443. Once this command completes, our load balancer is live and ready to serve traffic from our cloud storage bucket to the world. Let's do a quick review of the complete architecture we just built. A user's request goes to the single, global IP address of our load balancer. The forwarding rule sends it to the HTTPS proxy, which handles encryption. The URL map directs the traffic to our backend bucket. The backend bucket has Cloud CDN enabled, so it first checks if the requested content is available in a nearby edge cache. If it is, the content is served directly from the edge for maximum performance. If not, the request is served from the origin cloud storage bucket, and then cached at the edge for future requests. This combination of a global external HTTPS load balancer with a cloud storage backend provides a highly scalable, secure, and cost-effective solution for hosting static web content and media for a global audience. Thank you for your attendance. Please consider subscribing to the channel.